Okay, so 7.2 day 1, if we've got secant is equal to 2, well, secant is 1 over cosine. And if 1 over cosine is equal to 2, that means that cosine is equal to 1/2 b. If you don't believe me, you can cross multiply and solve to get that. Well, if cosine of beta is equal to 1/2, I meant beta, I know that cosine is x, so I draw my picture. I know I want to know where x is equal to 1/2. It's going to be these two places. I use my trig hand to find my reference angle of pi over 3. That means if I back up 1 from 6 pi over 3, I'm also at 5 pi over 3. So that means my different betas, I could get this beta, beta 1, could be pi over 3 plus any number of rotations, or beta 2, the second possible answer, could be this answer plus any number of rotations. 6, cosecant is 1 over sine. So if 1 over sine is equal to the square root of 2 over 1, I can cross multiply and solve and get that sine is equal to 1 over root 2, but that doesn't look like something on my trig hand until I multiply it by this well-chosen 1 to get this. So now since sine is y, I look for where on my trig hand do I have the square root of 2 over 2, and I get the reference angle of pi over 4. So if I'm looking for where y is equal to square root of 2 over 2, it's going to be these two dots where that's pi over 4, and this is not 4 pi over 4, but back up 1 to 3 pi over 4. So my two gammas that I might get are gamma 1, which is this, plus any number of rotations, or this dot right here, plus any number of rotations. 11, if you have this, again, my angle is just 2 theta. So I add and then divide. I get that the cosine of my mystery angle is equal to the square root of 3 over 2. Well, cosine is just x. So where's the x equal to the square root of 3 over 2? Well, it's going to be these two dots. My reference angle, use my trig hand and find pi over 6. But then if this is 12 pi over 6, and I back up 1, I'm going to be at 11 pi over 6. So there's my two dots. So that means my two thetas, I could either have 2 theta 1, which would be equal to this, my angle plus any number of rotations. Then solving for theta 1, I get pi over 12 plus pi n. My other possible choice would be 2 times theta 2, some other angle. It's equal to this answer plus any number of rotations. Divide by 2 and you get this. So there are two different families of solutions, two different branches. Here, again, my angle is just 3 theta. So I'm going to work the problem thinking about what is my mystery angle, not focusing on the 3 theta yet. So when I solve it, I end up getting that sine of my angle is negative square root of 2 over 2. So since sine is y, I want to know where y is negative root 2 over 2. But then, to understand it in terms of trig hand, I find out where is positive square root of 2 over 2 for y. Well, that gives me a reference angle of pi over 4. So that means my other two dots are also going to have a reference angle of pi over 4. So that's why I have 5 pi over 4 and 7 pi over 4 as my two solutions that give me a negative square root of 2 over 2 for my sine. So that means I either have 3 theta 1 equal to my angle plus any number of revolutions. When I solve for theta by dividing by 3, I get this. Or I have that this angle must have been equal to this, so it's my second angle, so I'm going to call it 3 theta 2, plus any number of rotations. Dividing by 3, I get that. 15. Now again, I just have the sine of some mystery angle as a half, so don't worry about the stuff underneath here for a second. So if sine is y, and I want to know where sine is 1/2, well, y is equal to 1/2 up here at these two dots. On my reference angle, my trig hand gives me pi over 6. So this one over here must be 5 pi over 6. So that means my mystery angle is either equal to pi over 6 or 5 pi over 6. So if my mystery angle is pi over 6, then I can also add any number of revolutions. But remember, it just wasn't a mystery angle. It was actually this. So now I can plug that in there and solve for theta 1 by subtracting. And this is my answer, but now I just want to make it look nice. So getting a common denominator, I subtract, and I get that theta 1 is equal to negative pi over 12 plus 2 pi n. Similarly, our mystery angle could have also been equal to 5 pi over 6. So I set it equal to 5 pi over 6 plus my 2 pi n. Solving for theta 2, I get 7 pi over 12 plus 2 pi n. 18, the last one, is kind of similar. Just see it as the cosine of some angle, not worrying about the angle for now. Well, cosine is x, whereas x equal to the square root of 2 over 2 on the unit circle. It would be over here at this dot or this dot. So that gives me a reference angle of pi over 4. So this dot down here is 7 pi over 4. So my mystery angle could be equal to pi over 4 plus any number of wasted revolutions. But my mystery angle was just this. So solving for x1, I add pi over 4 and then divide by 4. Similarly, my mystery angle could have also been 7 pi over 4. So I take my mystery angle and set it equal to 7 pi over 4 plus 2 pi n. That mystery angle was just this. Solving for x2 gets me this, and I'm done. Great work, and I will see you next time.